All right, if you guys can turn to page 8. So we're going to start circles, but I think you've seen a lot of it already. We're going to involve distance and midpoint formula to find some of this information that we need, but a lot of it's going to feel like review. Okay, so distance formula, okay, distance between 2 points, basically it's a rearranging of Pythagorean theorem, just like how you found hypotenuse, right? You would take the square root of a squared plus b squared. Same idea, it's just that we have to involve the difference of the x and y's to get that distance of the legs of the triangle. Okay, midpoint formula. Imagine finding the average between 2 numbers. So to find the average, you just add the 2 values, divide by 2. So we find the average of the x's, we find the average of the y's, and the result is the midpoint that sits between the 2 starting points. Okay, so just for practice, given the 2 endpoints of the diameter of a circle, find the diameter's length. So this is going to be helpful later on when we're going to use that diameter length to help us find the radius. So we're just going to use distance formula for number 1 and 2. Okay. So I'll treat the 1 and 7 as x1, y1. I'll treat the 5, 4 as x2, y2. And I'll just go through distance formula. Okay, thank you. Okay, so subtract the x's, square that, and then find the difference of the y's.
Do we get a calculator for this unit or no?
No calculator. So these numbers should all end up being, yep, easy. Yeah, easy to find. And then if we can't, then we'll just make our best approximation, especially for later on. So, but I think as of now, no calculator. Okay, try number 2. Okay, so distance formula 1 and 2, you've used it quite a bit. For number 3, given 2 endpoints, find the center of the circle. So that means we're finding the midpoint. So we're going to average the x values, average the y values, and that's going to be the midpoint. Okay, is that what you guys got as well? Okay, you've seen circle formula before, but we'll just revisit how we got there. Circle is a set of all points that are the same distance from a fixed point, and that fixed point we call the center of the circle. The distance between the center to any point on the circle is called the radius. Suppose the center of the circle is translated from the origin, HK. You basically use distance formula to allow us to find that radius. Okay. The standard form of an equation with a radius r and center at HK will look like this. So you can kind of see that Pythagorean theorem notation in our circle standard equation. All right, go ahead and turn to page 9. Okay, questions? You guys okay at this page? Okay. So it says, given the standard form of the circle, okay, so here we have standard form. Monday, we're going to be working on problems where we have to get it into standard form using completing the square. But for now, everything will be in standard form. Identify the center and the radius. So the center is going to come from your HK, and your H is always with the X, your K is always with the Y, and you're always pulling the opposite sign, just like how we did parabolas. So what do you think the center is for number 5? Yep. And then the way you find the radius, you're going to look at the other side, the constant on the other side of the equation. And it's always going to be the square root of the number that you see in front of you. So for the most part, it's going to be a number that's different than what you see here, unless it's 1. Okay, if it's 1, the square root of 1 is still 1, but usually it's going to be a number smaller than what you see here. It's going to be the square root of this number. So what's the radius going to be? 3, yeah. Square root of 9 is 3, so r equals 3. Okay, so we're going to practice sketching the circle onto our graph. You're going to start off with your center, negative 6, 2. And to help us create a circle that fits what we want to build, just plot points 3 units away, up, down, left, and right. So if you can plot points above, then you can use the 4 points to create a pretty good graph of your circle. Okay, so from the center, I'm going to count up 3 units, down 3 units, left 3 units, and right 3 units. And then using those 4 points, just try to create a circle out of that. Okay, number 6, we don't see a parentheses with the y, so, but technically we can think of this as hiding what number here? 0, yeah. So if you want to write it in standard form with parentheses and the 0, you can, but you can also just understand that there's a hidden understood 0 there. Yeah. So square root of 30, maybe that's hard for you to imagine, but if you just think about the closest number, right? What are two numbers multiplied together that can get you close to 30? That are the same. Yeah, 5 and 5 gives you 25. 6 and 6 gives you 36. So maybe somewhere between 5 and 6. We'll just make our best estimation and say like maybe 5.5. But it doesn't have to be exact, but we just, we can always look at a number and have some ballpark values, right? We don't feel lost without a calculator. That we know square root of 25 is 5, so it has to be a little bit larger than 5. Okay, let's look at number 7. Okay, so it says write the standard form of the equation of the circle, describe and graph the equation. So we know the center is our HK, we know our radius is R, we can just fill in to our standard form. You can put 36 or do 6 squared, either way is fine. But we can take this information and go ahead and create our circle. Okay, now look at number 8. Number 8 requires us to do something a little different. We saw this yesterday with a parabola problem where we're given a random point that sits on the circle, and we may have to use it temporarily to help us get to that radius, because we don't know what the radius is, but we do have HK from the center, and we also have an arbitrary point that we can use temporarily. So we can treat that arbitrary point as xy. Okay, we'll insert into our standard form, and that will temporarily fill in and allow us to get to that r, right? If we get to that r and we have that hk, we can write the standard form of our equation. Okay, so replace every xy with 1, 2. Replace your hk with -2, 6. So now we can write our equation. You have your HK, you have your R. So finally, here's our equation. Okay, and sketch your circle as well. You may be a little bit off the grid here. Okay, number 9, center at -3, -2, and tangent to the line y = 5. So you know that your circle is going to skim the surface of that horizontal line, and that's going to help you gain an idea as to what the radius could be. So plot my center, -3, -2. So tangent to the graph of y = 5. So I'm going to just sketch that horizontal line there. So if the circle is going to skim the surface, we know that there's going to be a radius, there's going to be a point directly at that point on that line. And if we know where that point is in the center, then we know we can kind of count and just figure out what that radius is going to be, right? So how far is that? 7. So you know that your radius is 7. So okay. Endpoints of the diameter are -2, 1, and 6, 7. If we have 2 endpoints of that goes through the center, we can just do the midpoint formula. Let's practice going through midpoint formula. I know right now maybe it's let's see, -2, 1. Yeah, let's go through the midpoint formula to get to that, even though we can plot those points. Okay, let's find that midpoint, and then from there we can decide what the radius is going to be. Okay, so midpoint. Average the x's and then average the y's. So the midpoint just happens to be the center as well. It's kind of hard to count what that distance is, but what we can do is we can take the center and a point and find the radius that way, right? Just like how we did this previous problem, right? If I have an HK and an XY, I can always insert into my formula to get my radius. So I'll treat the center as the HK, and then I'll just choose an arbitrary point. I'll choose -2, 1, and now assign those as X and Y, and just like how we did number 8, we can take a center and a point and find the radius that way. (16 + 9 is 25). So R is equal to square root of 25, which is 5. Once you have your center and your radius, you can finally write your standard form equation. Okay, next page, page 10. Okay, so classwork, pages 10 and 11, and I'll work through as you guys are going through as well. I'll leave it on this page for another minute. Okay, does anybody still need this page? Oh, sorry, yeah. So let me draw a circle. So from my center, I can just count 5 units over. I just have some additional points and just try to get the circle to go through all those points. Okay, page 10. Yeah. I guess just to see if it was easy to find the midpoint, but they're kind of diagonal from each other, so we kind of have to rely on midpoint and distance to see things a little better. Yeah. But yeah, I guess technically we could have just gone directly into the algebra without touching those points, or without plotting those points. Okay, page 10 and 11 is our classwork. I'll just work through these problems as you guys are doing them as well. Go ahead. Okay, everybody good with 1 and 2? Four thirds is just 1 1/3, so you know it's just going to be a little bit more than 1 unit. think you're pretty good with 3 and 4. Okay, page 11. Remember, when it says y equals a number, like y equals 3 or y equals 4, those are horizontal lines. If it's x equals 3, x equals 5, those are vertical lines.
And let you get R. Number 6.
For number 6, it says tangent to the y-axis. So if it's tangent to the y-axis, that means it's got to skim the surface of that line. So if it skims the surface, you know that it's going to have to touch that point. If it touches that point, then it's going to, we can count that distance and find the radius.
Okay, so if it said tangent to the x-axis, you would do 2.
Yeah, that's right. Yeah. So you know that the x-axis, the distance from that axis to your center will be the radius. All right, everybody okay with 5 and 6? Okay, is that what you guys got for 9 through 11? Okay. No. Yeah, no, no. Yeah, probably number 11 is the most work intensive because you have to go through midpoint to get to the center, and then pick another point, and then use the equation to get to the radius, and then you can write the equation with your center and your radius.
You have also done -6.
Yes, that's right. Yeah, you could have used 2, 3, or -6, -5. You would have gotten the same radius, or square root. So either point is fine. Typically, we just want to choose the point that we feel is easier to plug in. That's why I chose 2, 3. But -6, -5 would have worked.
How'd you get 18 for number 10?
Let's see. So this is my point on the graph. That's my xy. 2, 3 is my hk. I inserted them into the equation to get my radius. So 5 minus 2 squared, and then 6 minus 3 squared to get to my r squared. So 9 plus 9 is 18. That's my r squared, and that's enough to fill the right side of my circle equation. Let me know if you have any questions. Otherwise, I'll just let you guys finish up and check your couple pages, 8, 9, and 10. Sorry, 8 through 9 through 11 for your classwork.